So far, we have learned 4 different types of factoring. So I summarized all of them here in this drawing. As you can see that when we have a factoring problem, we may not know which type it is. So we have to start with, we always want to start with the GCF. Doesn't matter how many terms or what it looks like. So we always want to check, do they have any GCFs? After we check that, maybe they don't. If they don't, you move on to count the number of terms. Of course, if they do, we should go ahead and factor out the GCF. All right, so once we're done with GCF, we are going to count the number of terms. If they have 2 terms, check if it is difference of 2 squares type. Maybe it is, maybe it is not. If it is, and then you continue using the formula. Again, remember the difference of 2 squares formula looks like this: something squared minus something squared. So you will have you put 2 copies, let's say A and B, you will put 2 copies, 1 copy in here, 1 copy is here, and 1 copy is of B here, 1 copy is of B here, and then use minus and plus, plus or minus. Now, if they have 3 terms, and check if it is a trinomial. If it is, and you will draw a 2 by 2 box and break down. So usually a trinomial looks like this. So you break down the first one here, and then you break down here, and then cross multiplies, add up to the one in the middle. And if they have 4 terms, and you will do grouping. And usually if you have 1, 2, and 3, and 4 terms, so you can put the first 2 in a group and last 2 in a group, and apply GCF on the terms in each group. And once you break down each one, you should be able to find something else in common and take that out. So the technique is always check GCF and then count the number of terms. So let's look at these examples here. So when we get a factoring problem, we start with GCF. So let's take a look at the numbers first. 12, 12, and 3. So they do have a GCF, which is 3 here. And when we look at the variables, one of them has 2 copies, 1 copy, and no x at all. So they don't have x in common. So we can only take out or factor out at 3. So I'm going to write down 3, and we're going to divide each of these by 3. So I got 4x squared divided by 3 minus 4x. Negative 12 divided by 3 is negative 4. And positive 3 divided by 3 is positive 1. So when we get here, so we're done with GCF. We already factor out the GCF 3. Now what we're going to do is we're going to focus on what's in the parentheses, because we still have a square. We may be able to factor further. So now we just count the number of terms. So we have 3 terms here. As you can see, we have here first term, second term, and third term. And it is a trinomial. So we're going to draw a 2 by 2 box and break down on your scratch paper. Okay, so first step, we break down 4x squared. Now, in order to break down 4x squared, first let's break down the number in front of it, 4. Now, there are 2 ways to break down 4. So whether we can either we can try 2 times 2, or we can try 1 times 4. If you don't know, so you would just have to randomly pick one pair and try. So let's say I'm going to pick 1 and 4, and actually the correct answer should be 2 and 2, but let's say we try. And after you break down 4, you're going to break down x squared, which is x and x. Now let's break down positive 1, and there's only one way to break down 1, so it's 1 times 1. But of course, don't forget there's other possibilities that both numbers may be negative. But I'm going to try positive 1 first to see if it works. But notice that if I make both of them positive, when I do cross multiplies, I'm not going to be able to get negative 4, because I'm going to get a positive 1x and a positive 4x. So that tells me I shouldn't use positive 1. I should use 2 negative 1s. Now let's do cross multiply. So I get that diagonal gives us negative 1x. The other diagonal gives us negative 4x. When I combine it, I'm going to end up with negative 5x. but that's not what we need. We need negative 4x here. So that tells me, by the way, that just tells me 1 times 4 doesn't work. So let's try the other way. So I'm going to have to, because we don't really have another way to break down 1. That's the only way. So that tells us 1 times 4 is not correct. So let's try 2 and 2. And now let's do cross multiplies again. Negative 2x and also negative 2x. Combining them gives us negative 4x. So that does match the one in the middle. So this tells me this is the correct answer. So I'm going to write down the answer horizontally. By the way, this 3 we have to bring down because that comes from the first factoring step, GCF. And the second step, we're not breaking down 3, we just bring it down, but we are breaking down the second factor, the long expression here. So we got 2x minus 1 times the second one is also 2x minus 1. So if you want to put 2x minus 1 squared, that's fine. But if you want to just leave it as the 2x minus 1 times 2x minus 1, because when you have 2 copies, yes, you can use a square, but you can leave it as it is. Now let's look at the second example. So first I'm going to try GCF, but notice that they don't really have anything in common. So I am going to, there's no GCF here. I'm going to, once you determine there's no GCF, you just need to count the number of, so you can count the number of terms. And if it's 2, this brings 2 squares, 3 trinomial, maybe, and 4, maybe grouping. So let's take a look at how many terms we have. So we have 1, and 2, 3, and 4. So remember, terms are separated by plus sign or minus signs. So here we're going to put the first 2 in the group. So these 2 I'm going to put them in the group, and these 2 we're going to put them in the group. So let's factor group 1. They do have x squared in common, so I'm going to take out x squared. And then after I take out x squared, we're going to have to divide both of them by x squared. That gives me x. Divide by x squared. They cancel, so that gives me minus 3. Now let's factor group 2. Group 2, 2 and 6, they both have 2 in common, but it's a positive 2, so don't forget there's a plus sign joining these two groups. So we're going to take out a 2 and divide both of them by 2. So again, minus 3. 6 divided by 2 is 3. And now we're not finished yet because we still have a plus sign here. But notice that we have another common factor, which is x minus 3. So we're going to take out x minus 3. From here, we have x squared left. From here, we have a plus 2 left. So once you see your final answer has multiplication something times something, and that is when you can stop. But you cannot stop here because you still have a plus sign. Now we look at another example here. So first, start with GCF. And when we look at 5, notice, and we look at the numbers, we have a 5 and 80. They both have 5 in common. So we're going to take out a 5. And x fifth and x, they both have x in common. So let's take out a x. So we got the GCF 5x. So let's divide both of them by 5x. So they cancel. I have x fourth. 5 minus 1 is 4. And divide by 5x here. Bring down minus sign. 80 divided by 5, that is going to give us, if you do a long division a little quick here, 5 goes into 8 one time, and then 5 goes into 30 6 times. So the answer should be 16, and x cancels x. So now we have a GCF 5x, which you can bring down because we cannot really break down x any further. But x fourth minus 14. There's a fourth power. That means possibly we can break it down. So since we already took out a GCF, they shouldn't have anything in commons anymore. We're going to count the number of terms. So apparently we have 2 terms here. So we have x fourth first term and the 16 the second term. So if we have 2 terms, check if this is the difference of 2 squares type. And which is because we do have a difference. Also, 16 x fourth can be written as, so let's see if we can turn both terms into the square format. 16 is easy, 4 squared. X fourth, as we can see, we can turn that into a square squared, because 2 copies of two twos will give us 4. So now I can apply the difference of two squares formula. So let me use a different color for the base so we can see clearly. So here we're going to break this down as 2 factors. So notice that the red 2 tells us, here tells us we have 2 copies of x squared. So I'm going to have to put 1 copy in the first pair of parentheses, another copy in the second pair. And again, we have this 2, exponent 2 tells us we have 2 copies of 4. So I'm going to put 1 copy in the first box and then the other copy in the second box. And also use one of them use plus, the other is minus. Okay, now, so we use the difference of two squares formula. And notice in the answers we got, we still have a square here and a square here. So that means maybe we can still factor it further, but maybe not. So we need to check. And again, the ones where we already have, like 5x, we cannot break down any further, so we just bring it down. So that's the first factoring technique we use, the GCF. And the ones we did a breakdown x fourth minus 16 into these two, but these two maybe we can still break them down. Just like when we have numbers, for example, 16, you can break down as 2 times 8. 2 you cannot break down, so you bring down, but 8 you can break down as 2 times 4. And then maybe so 2 and 2 you cannot break down, but 4 you can still break down as 2 and 2. So maybe this process will continue quite a few times until you reach all the numbers that cannot be broken down. So same thing here. So when we get to this step, so we did it first, we broke down the original problem, and to get this, and then we were able to break down further to get this. And now we're going to check whether we can break down this part. X squared plus 4. We don't need to check GCF anymore because we already pull out the greatest common factor. There's nothing in common. And 2 terms, so we count the number of terms. We got 2 terms. That means maybe it's difference of 2 squares. But unfortunately, we don't really have difference. We have a plus here. And we don't have a formula for the sum of two squares. So we only have the difference of 2 squares. So that tells me I cannot break this down. So I'm going to just have to copy down x squared plus 4. But the one in the second pair of parentheses, we do have difference of 2 squares. Because x squared minus 4, first of all, we see difference. Secondly, we see a square. We just need to rewrite 4 as 2 squared. So now we can apply the difference of 2 squares formula one more time to break this down as x plus 2 and x minus 2. Because we have we have 2 copies of x, one in here, one in there. 2 copies of 2, one in here, one in there. And now we cannot break down any further. So if you check, we cannot break down this, we cannot break down this, we cannot break down x, we cannot break down x. So that's the final answer.